In the previous video, we have looked at how to train an image classification model using Sagemaker's inbuilt algorithm. Today, we will train the same image classification model but using TensorFlow and transfer learning. Now, before watching this video, please watch the previous one because some of the important concepts we have covered in detail in the previous video, we will skip those concepts in the present video. Okay, so please watch the previous one, then only you will be able to understand this video. All right, first let's start with the data preparation. So for the inbuilt algorithm, we have the training images and the corresponding training annotations in the form of this LST file, right? And similarly, we had the validation images and the corresponding validation ground truth file. Okay. It's a little easier using TensorFlow because the way we are going to organize the data is slightly different so that we don't need this LST file. Okay. So that was using the classification using the LST format and inbuilt algorithm. But TensorFlow uses the subfolders. What I mean by that is, so within this train images, we will organize the images such that the images belonging to each class are in a separate folder. So these are all the images of Daisy. And then these are all the images of Rose. And then sunflower, right? So this way, we don't need to explicitly create an LST file, right? As we have seen previously, the LST file, if I might open here, yeah, it essentially have this information that each file, the class label, right, in the form of these integers. But we can organize all these images into one folder and then all these images into another folder and finally these images into a third folder so that we don't need to create this LST file, right? So that's what the case with the TensorFlow algorithm, right? So we don't have the annotations or the ground truth folders. Okay, that's one main important difference. Now this works when we have only one class for each image. When we have multiple labels, which is called multi-label classification, this method don't work. So in that case, we again need to explicitly create the ground truth or the annotations file. Okay. All right. Let's jump into the code. Now, the code for all these videos are provided on GitHub. And these are some important URLs from Sagemaker blogs as well as the Sagemaker GitHub. All these links are provided either in the notebook or in the description below. Okay. All right. So again, some of the important concepts we have discussed in the previous video, we don't cover them in detail. We will be contrasting this training of this model, which is not inbuilt, with the previous one, which is inbuilt, right? So it's important you watch that video first. All right. Okay. So in a previous video, we have used only this functionality to get the Docker image, the training Docker image. And also the training as well as inference image are the same for inbuilt algorithms. Now, this algorithm coming from TensorFlow, we need to explicitly provide the model artifacts as well as the training script. Okay, I'll show that in a minute. So we have seen the hyperparameters, the estimator things before. So this can be removed. I am loading it separately. All right. So let's get to the important or the main differences, right? So as you can see here, we don't have the number of classes and the number of training images explicitly defined, okay? Which was the case when we use the inbuilt model. Here, our data path is different. The bucket is the same, but this time we organize the data into these subfolders, right? Which is this one. The subfolders. Yep, the subfolders one. All right. So, okay, it's not TensorFlow. Today, it's a PyTorch model. So we are going to train this image classification model using the PyTorch framework, and the algorithm is this MobileNet version 2. Okay, and we want to use the latest version. Now, here, as you can see, there are these three things we are retrieving, right? So we are retrieving the Docker image. We are retrieving what is known as source URI. This will contain the entry point or the entry point, the Python script. And then this will contain the model artifacts, the pre-trained model artifacts. Okay. All right. So again, here we simply supply the model ID, which is this PyTorch MobileNet version 2, and then the latest version. Now the image scope is training. Okay. Because for these non-inbuilt models, the training and inference images are different. So we need to provide the scope as well. Okay. All right. And then this one is the train instance type. Again, I think we are using this cheapest instance, GPU instance available, right? So that will retrieve this Docker URI. Okay. All right. So as you can see, this one, it's a PyTorch in the training mode, the model version, and it's GPU and Python 3.8 version. Okay. As we discussed, image or computer vision models, they require GPUs. Then we are retrieving this, what is known as the source URI, right? This basically contains the entry point. Okay. So that will look like this. So within the source directory, there will be a Python file called entry underscore point dot py. Okay, right? That will contain the code for training the model if we are training, or for inference if we are doing the inference. And then this third one, again, we supply the model name or the ID, the model version, and the scope. Okay. This will extract the pre-trained model artifacts. So this one, right? So this is very similar to the zip file, which is created after we training the model on S3, right? But this contain the model weights as they are, right? Again, if we are doing the transfer learning, we are going to update the last layer and it waits for our own training data. Okay. Again, to quickly summarize, if it's an inbuilt algorithm, we just need to retrieve the Docker image, and we don't need to worry about the pre-trained model artifacts as well as the entries script. Whereas if it is not a inbuilt algorithm, we need to extract these two explicitly, right? That's the main difference between training an inbuilt algorithm versus not an inbuilt algorithm. This is very, very important. The reason I'm stressing is once you know this difference, the process is very standard, right? Whether it is object detection or text classification or maybe image generation or maybe even numerical data, right? So the process will be very similar for inbuilt algorithms, and it will be very similar for non-inbuilt algorithms. Okay. All right, we extracted those three variables, and then for the model we have chosen, we can extract the default hyperparameters. Again, we simply need to supply the model. So everything depends on the model and its version. So we have extracted the default hyperparameters, right? Then we can change them. We can update if we want to do for, let's say, more epochs, etc. So for example, this model, it has only these few hyperparameters. So by default, train only top layer. So this is what we are referring to as transfer learning, right? So we are training only the top layer, right? And then the number of epochs. So here we have explicitly set the number of epochs to 5. So we have modified a hyperparameter. Again, the learning rate, the batch size, if we want, we can change. Reinitialize top layer. So we are just keeping, I guess this one, the previous layers, the weights as it is. Then here we are setting the output path, and then the process of choosing this estimator and the rest of it will be pretty much similar. For any model, we train with Sagemaker. Okay, so the default role, the train image. In addition to train image, we are supplying these two image URI, model URI, source directory. Yeah, so these three information, right? So basically the source directory, this contain the entry script or the entry point script, which is the transfer learning.py, right? So this source we have extracted from here. So this is also a zip file, and it contains that entry file. So you can unzip this file, and you will see one of the files is this transfer learning.py. Okay, and the other one, model URI, which contains the initial model weights. This is that one, right? So this additional information we have extracted, we have supplied in the form of these three variables. The model initial weights and the source directory, which contains the code what to do, and that file name is transferlearning.py. Okay, these are standard again, as we said before. So instance count and the instance type, and we are setting these hyperparameters from here, and finally the output path where we want the model artifacts. Now the data channels, it's different because our data format or the data organization is different, right? So this time we don't have any ground truth files, right? Now this is not necessary. For some, even appending this slash at the end of the path is necessary. That will be the case for object detection models using TensorFlow, okay, which we will cover in the next or the video after. So we are simply defining these two paths. Where are our training images as well as where are our validation images. We don't need to provide the ground truth because we have organized the data such that each folder contain only images related to that particular class. Okay, so that's our data channels. And then again, get the timestamp and define a unique job name. So it's this flowers classification. It's Jumpstart TensorFlow. Okay. Then we simply fit the model. So we just need to supply the data channels and then logs is equal to true. I guess this will write the logs here and then the job name. So this is the job name. So again, this format will be the standard. So it just says, okay, I'm going to do a job with its with this name, and I'll prepare the instance. I'll download the required data and then start training. Okay. All right. So it's unlike the previous model, we have a little bit easy way of accessing the information. So towards the end, we have it's displaying the training and validations accuracies during each epoch. Okay. So this is the best accuracy. The job is completed, training and billable seconds. Okay. So it did not explicitly say I have uploaded the model artifacts to the output folder, but it has done. If it's saying the job is completed, that means it has done that. Now, as we discussed, as this is not an inbuilt model, the process of deployment is also different. Okay. So we start with inference instance. Now this don't have to be GPU, because during inference, there will be only very few calculations as compared to during the training. So for training, we need GPUs, but for inference, even small instances which can fit the model into its memory will be able to do. Now, so the inference image or the Docker is different, right? That's what we were discussing. So now this time it's same as before, but this time image scope is different. So for the inference, the Docker image is going to be different from the image which we used for training. This one, right? So this is the case for non-inbuilt models. Whereas for inbuilt models, same Docker is used both for training as well as deployment or inference. For non-inbuilt models, it is different. So that's why before the model deployment, we need to get the image URI for the inference for the model and version we have used for training. Okay. All right. And similarly, the entry point will also be different. Okay. So this time it will be inference.py, whereas earlier it was transferlearning.py, right? Now, what about the model URIs? See, this time we are not retrieving the model URI. You know why? That's because we have created a new model with new weights, and that file is already on our S3, right? In that output path we have specified. So that's why we are extracting only these two variables, the train image URI and the inference script using this source URI. We don't need to extract the model URI because it is already sitting on our S3. Okay. So again, we can have some model name, endpoint name, or we can leave it default. So in that case, it will use the job name for model name, endpoint and endpoint config name, right? Again, the focus of this video is not inference, but just to show you that the model we train is working. So here we are using the estimator to deploy the model. And unlike before, we need to provide the entry point script. And in addition to the image URI, this is the image URI. We are also providing the source directory. And these are just names and the instance type, right? So the three standard things: model, endpoint, endpoint creation, that will create an endpoint, And then in order to do the inference, we are accessing the SageMaker runtime, just opening an image. This is slightly different for different models. Some models take this bytes array, some models takes the image as it is. So yeah, so just invoking the endpoint with its name, so we can identify each endpoint just by using its name. And then this is our image payload, right? So this time the response is much more user friendly. Now when we trained using the annotations file like this, it does not contain information about what the class name is. It contains only the class IDs. So the model has simply returned 3 probabilities for each class. Whereas this model is reading the data from folder structure like this. It takes the folder name as the class name. Okay. Now, because we set this response to be verbose, it has provided in this nice user-friendly format. By default, it will only return the predicted label. Okay. So because of this verbose, now it has provided the probabilities for each class and the labels we have, the 3 labels. Okay. And finally the predicted class, which would simply be the one with highest probability. So in this case, the first one, I probably organize the probably either this order is fixed or it will return such that the first one always contain the highest probability. Then in that case, the order of this labels will change. Okay. Again, make sure you delete the endpoint to reduce the cost. All right. So we will have follow-up videos where we will do the batch inference and we will get the predictions on all the validation images, and we will access this information for each image. We'll compare against the ground truth. We will compute various validation metrics such as confusion matrix, the precision, recall, etc. etc. Okay. That's all for today. Thank you very much.